Selfishly, I worked very hard to get him to come here tonight. He may not realize it, but we've been trying to get him to come in for a while. And so I think he's going to have some very interesting information for us. He's obviously a leader in climatology throughout the world. He's testified before Congress many times. He's been involved in all the high-level climatology groups throughout the world. He's currently a distinguished professor of atmospheric science at UAH. He's also the director of the Earth Science System Science Center at UAH. He's also, as it says right here, the Alabama State Climatologist for the state of Alabama. And his claim to fame, if you know anything about him at all, is that he and just Dr. Spencer, right, was waiting for the waiting for it. Well, no, I mean, he introduced measuring temperatures from space, and it changed everything because it much more consistent data, a lot more data if needed, and so he's been a leader in measuring temperatures from space for 3 decades now, and he's done that all from UAH. You've been here the whole time, right? So without further ado, I'd like to introduce Dr. John Christy.
Thank you very much. Will the lights be necessary, or does it flush out the screen at all?
Well, we could probably turn on the lights in the room back there. You want to try that? See if that works? Does that help everybody? There's another room over there too. Come on, man. Run!
This way I'll be in the dark.
Is that enough light for everyone?
Yes.
Yeah.
Okay.
We'll get some chairs, Greg.
Ooh, not for the camera.
I just want
Oh.
Yeah, 2 up front, Greg.
Dr. Christy just disappeared in the camera, though.
that was the plan.
Ah, it must have been.
And here.
Now we tell you.
I'm just rushed in here. I spoke down at the Homewood Public Library down south of Birmingham this afternoon and rushed back here to make this appointment. I am your state climatologist appointed by the governor. In fact, the first time I was appointed was at the halftime of the Auburn, Alabama game in 2000.
Who won?
I wasn't there. It was done in the skybox and Governor. We're going to talk about climate change. And as I usually start my talks by saying this is going to be different than most climate change talks you've heard, for 2 reasons. One is I'm an actual climate scientist. Most of the talks you hear about climate are by people who think they know something about climate. I started making climate data sets over 50 years ago, so I've been building this career. This is what I do for a living. My degree is in climate dynamics itself. And the second thing is it's going to be a different take on climate change of what is typically brought out in the media and so on. Well, today climate change is a science issue, and I think I can speak to that as an expert in many things about climate. It's a political issue. I've testified before Congress 20 times now, and before many other kinds of panels and things. It's a moral issue. And I say I think I'm qualified to speak about morality because I was a pastor and a missionary in Africa, so I thought very deeply about moral things, what's good and what's right, and so on. So I think I can speak to all 3 of those professions here. So let's start here.
Amen.
Alabama and 25 other states are in a desperate fight with the regulatory activities of the federal government. And you say, well, wait a minute, isn't Trump in charge? Yes, but what has happened from the last administration, and I'm going to hit the last administration pretty hard here from personal experience, is that the regulations were put in place. And so there are things that have to be written. They aren't laws because Congress never passed any laws about climate change. It's only the regulations that came through the executive branch that are being dealt with right now. So in fact, the EPA rules on CO2 will further increase the cost of your energy and mine they already have and will not affect the climate, although the Supreme Court has put a stay on one of the biggest ones, the clean power plants. And that's in the process of being dealt with right now. And I can't tell you of all the legal issues I have to be involved with almost daily now, from coast to coast, of lawyers calling and needing advice about these kinds of issues. Well, here's a little factoid. Alabama generates about 153 million megawatt hours of electricity. We consume about 86 million megawatts. We export about 67 million megawatt hours, mainly to Tennessee and Georgia. People love electrons. We produce them and they buy them, because electrons are just great. My home state, California, generates about 200 million megawatt hours of electricity. California consumes about 260 million megawatt hours. So California imports about 60 million megawatt hours. It's almost impossible to generate electricity in California anymore. They almost make it a law against trying to do that, unless you have a solar panel or a wind machine. Now, the grid doesn't work this way, but if you can kind of look at this and say, my goodness, if Alabama didn't produce that much extra, California couldn't survive because they need extra power. Now, so the actions in California, however, and copied in other states, are driven by the claim that human-caused climate change is dangerous. And if that is true, and the legal machinations going on, that leads to tremendous threats to our economic livelihood here. Because can you imagine how much, if we send 68 million megawatt hours of electricity across the border, we charge for that, how much money comes into our state? That's an economic threat to us, these regulations are. Now, George Bush, back in 2006, State of the Union, said America is addicted to oil. I don't think he was right when he said that. Because what we are addicted to are these things. It's what we like. We don't care how we get them. What we like, long life and good health, progress, we like affordable services, we like freedom of mobility. And you know, when you have freedom of mobility, you can actually have an economy that works, because you can get a good or a service from one place to another when you need it on demand. And if you lived in other countries, as I have, you'll find that that really is an economic development inhibitor. You don't have freedom of mobility. We like food, and we like in big quantity. Natural landscapes, we like clean air and water. And these things we can have if we have affordable energy, principally in electrification, transportation, and industry. Those are the three big sections on which we base our energy. Now, that energy comes primarily from carbon. We either burn coal, natural gas, oil. Nuclear provides, this is globally, nuclear provides about 5%, hydroelectric power about 3%. The other renewables are just a teeny tiny fraction. They're very expensive. I'll go into that a little bit. And so they're just not making any inroads here, because you don't want to pay 5 times more for electricity than we can get it now. Although the federal government, previous administrator, wanted you to pay more for your power. Now, a byproduct of carbon, of course, is carbon dioxide. I mean, that's the whole point. You oxidize carbon to get the thermal energy out, and it's non-toxic. It invigorates the biosphere. We have now more than 2 decades of Landsat and other kinds of images from satellites that we can actually see the greening of the planet. Carbon dioxide is plant food. We actually measure the growth of the green world around us, because CO2 helps things grow. In fact, the stomata, you know, the little things on the bottom, the mouths on the bottom of the leaves, when they open, they draw in CO2. At the same time, they also respire water. And so with more CO2, they don't open as much, they don't lose as much water, they become more drought tolerant with extra CO2. That's one of the factors that helps plants grow better with CO2. So, and it increases food production. It's estimated that about 1/6 of the food production we have, plant food production, therefore animal as well, is due only to the extra CO2 we put back in the atmosphere. Okay? Can you imagine 1/6 of the world's food supply due to the extra CO2 we put back in the atmosphere? These kinds of pieces of information are just not brought out to you in the typical presentation of these things. So, since CO2 is just all good, I mean, it's just great stuff. The only issue is it a problem for the climate? So we better check that. You know, that's one thing we need to check. So, as I said, it's a science issue, a political issue, and a moral issue. Let's look at science first. All science is numbers, the biggest font I could put on that page. That's the paraphrase Lord Kelvin. He talked about, you can only talk about science when you can measure things and talk about numbers. That's the only way you can really talk about numbers. You cannot talk about how much you love a tree or a whale. That is not science. This is science when you can put things in numbers. So, how do you test what the last administration constantly called settled science of the popular view of climate change? In other words, humans are destroying the planet with all this CO2 we're putting in the atmosphere, which I've already since debunked. CO2 helps the biosphere, helps the world. So how do you prove humans are affecting the climate? So it's not a question of what is happening with the climate, but why. And here's a dirty little secret in all of climate science. No one can prove carbon dioxide is causing anything in terms of climate. There is no instrument that tells us, oh, this thing changed because of carbon dioxide. You think about it scientifically, and we'll talk about it a little bit now, that you really can't prove. So, here's a tip. Take a climate model simulation and show you can reproduce the current climate only with extra CO2 is added to the model. So you take your climate model, run it without CO2, run it with CO2, and if you match the current climate with CO2, then you could say, well, that's some evidence that CO2 is causing climate change. So, that's called a hypothesis or a claim. We will look at the largest response according to the theory, the temperature of the tropical atmosphere. So here is what the claim is from these modeling simulations. I took this from another presentation, but that's a guy in a computer model, you know. 40 years ago, I don't know. You know, you didn't buy a computer back then, you bought a piece of furniture. This is from the Canadian climate model, but what it is from South Pole to North Pole, surface to stratosphere. This is a cross-section of the atmosphere. Cross-section of the atmosphere all the way up, and North Pole, South Pole to North Pole. What the model says is this is what should have happened between 1979 and 2017. I picked 1979 and 2017 because that's when satellites were first launched. They were able to tell the global atmospheric temperature. We actually measure the temperature of this layer all around the world, this layer, especially in the tropics. So we now have a way to test that theory. That is the claim of climate models. That is the claim on which all those regulations from the last administration were passed. Okay? When we do that, this is what we get. The spaghetti is all the different climate models around the world. But this is the average. The red is the average. And the average, as you can see, is taking off like crazy. That's the claim of the theory. These are three very different ways of measuring the actual observed atmosphere. The satellites are here. Our satellite data set is a little lower than the average of these. The others are a little higher. We just published a paper last week that indicates that those other satellite data sets have spurious warming in them. So it's really not that much. In any case, what you see is pretty easy to see is that the real world isn't changing much. The models are just going like gangbusters. Well, that's kind of a picture that doesn't, you know, when you're speaking before Congress or something like that, you show a picture like that and the congressman goes, huh? So to kind of make it more simple, I didn't have those cartoons on there. But here's the average of the climate models. Here is the average of the observations. So now you can see what the climate model said should have happened over the past 39 years is not happening. In scientific language, we have falsified the claim. We have falsified the hypothesis because this is significantly different than this. In science, when your claim is falsified, you go back and make up a different claim or check your hypothesis. You don't just yell louder that you're right. That is what's happening in our world today, where these climate people are just yell loud. It reminds me of, I have a seminary degree as well. And when we were preaching class, I remember the pastor saying, now don't be like this guy. and he showed the notes of the sermon of this preacher that was preaching. And in the margin it said, "Weak point, yell louder." That's what we get these folks who, when they're shown they're wrong, they just yell louder. They don't rationally think about what's going on. In fact, you recognize this fellow? Who I've testified before his committees for 20 years now. His staffer called me one night and said, "Senator, as a presentation tomorrow on the floor, we need that chart that a U.S. senator could understand." And so we went back and forth the night before. They had to download a bunch more data and so on. But I came up with this one. He said, "Yes, they can understand that one." And so he then next day put it on the floor to demonstrate the very simple point. And this was back during the Obama administration. The regulations are based on this. The real world is doing that. What are we doing? This is wrong, what we're doing. Congress never did pass any of those laws. It was the administration doing regulations. So the Senate was trying to undo them, but they really couldn't. Now, in Alabama, we like to shoot things. So I thought I'd put another illustration up here. In science, when you build a model, one of the very first things you should do with your model is test it against the real world and see if it fits. Someone's going to be in a real big problem if there was a model of that footbridge in Florida collapsed today and find a problem. Here is the real world of the trend value of that tropical atmosphere that I showed. It's about 0.1 degrees C per decade. That's the real world. Your model should match that. Now, if I give you 102 bullets to shoot at that target, you ought to be able to kind of get a pattern and see what's going on there. Well, we have paid tens of millions of dollars per year just in this country, many more elsewhere, to create these models. I mean, it is an industry, and that's why it's so hard to get them to admit they're wrong. It's an industry. And this is the result. 101 out of 102 models missed the target. And the fact they all miss on that one side, that tells you there's a bias in the minds of the modelers. They want there to be global warming. They get paid more. Their ability to survive as a scientist depends upon their being alarmed and so on. By the way, that one model, it was right. You don't say that anymore. But the American models are all wrong, and that's so unfortunate because we think of ourselves as a leader in lots of science and technology fields, but in climate modeling, we just can't hit the target, not at all. But think about it, the federal government has almost been a gravy train for people who create alarm with this kind of issue. But you say, well, okay, the models are wrong, but you can just look around and see that global warming is just tearing up the world. I just watched a video before coming over here that all these people were saying, well, I just feel so bad about the world. I know this weird weather going on now. It's wrong. All science is numbers. Remember that? All science is numbers. If you have a question about something, go count them. Go measure them. See what's happening. This is the snow cover of the northern hemisphere since 1967. There is no trend at all. We still have snow every year. In fact, the highest in this whole time series here was just 6 years ago. The record snow cover of the northern hemisphere. The snow is still here. What about ice? See it. This is ice that floats on the sea. It doesn't have anything to do with sea level. The Arctic has warmed up and has gone into a situation where there's ice in the winter, but not so much in the summer. That's happened before in history. This is the first time. Climate is naturally varying. I mean, the nonlinear, chaotic system it is has many, many ways to create all kinds of variations. Antarctic ice, there was a series of storms that went around the Antarctic ice right here. In about 2 months' time, the ice cover dropped rapidly, but now it's freezing again. But even so, this trend is upward. This trend is upward. which no climate scientist predicted at all, at least of those that were thinking global warming was going to be a bad thing. This is the Greenland borehole temperatures going back 10,000 years. And what you see here is a nice picture, very good picture. This is the most reliable kind of measurement there is of past climate. And I mentioned that here. Someone was talking to me about, Carl was talking to me about hockey stick. And Michael Mann and I were on the lead authors of the IPCC in that period. And every meeting we had, Victoria, Canada, Christchurch, New Zealand, we were in Arusha, Tanzania, Paris, all these places. And I would say, this is the best temperature reconstruction. Why don't you put it in your chapter? He always told me he would, but it turned out it did not appear in his section of the chapter because it did not tell the story that he wanted. Because you can see here, 1,000 years ago, it shows warmer than today. That's back when Greenland was settled and the Vikings grew barley and had cattle and so on. And the period back here, 2 to 6,000 years BC, was much warmer than it is today. So that just tells you again that temperatures can be hotter and colder in the past. But Greenland's still there. It's not going anywhere. What about sea level rise? The sea level is rising. It has been for a long, long time. It's about an inch per decade right now. If you can't handle an inch per decade, you're in a real problem. Because if you live on the coast, especially the Gulf Coast, your problem is 20 feet in 6 hours with the next hurricane. That's your problem. It's not one. And sea level has been rising for a long, long time. In fact, between 15 and 7,000 years ago, it rose about 5 inches per decade for 8,000 years. Sea level used to be 400 feet lower than it is today. And Florida was twice as big as it is back then. Because all that water was in ice up on the ice caps. Oh, what about extreme weather? How many times has Al Gore said, extreme weather is getting worse? Al, count the events, measure the events. Of course, he is challenged to do things like that. We do, as climate scientists. Hurricanes, we can count. There's about 50 or so around the world any given year. And that number has not changed. It's actually a slight downward trend, but it's not significant. Hurricane frequency is the same. Hurricane intensity has not changed. It goes up and down from year to year. You all remember 2005 back here. That was a big year when the Atlantic hurricanes really spun up. But nothing is, it goes up and down, but there's no trend at all. Hurricanes, no trend in frequency, no trend in intensity. What about tornadoes? Tornadoes actually have a downward trend since 1954. You all remember this year, 2011, Alabama, had 63 tornadoes on April 29th, 27th, April 27th. It was, one of our recruiting tools at UAH is that we have a real big, I'm the director of the Earth System Science Center. I have about 90 people work in the center, and a lot of them do severe weather research. We have mobile radars and all kinds of stuff, LIDARs, upward pointing microscopes and everything. It's a lot of equipment to take out there. But when we had that event, there were so many tornadoes and tornado tracks, and our graduate students always helped with this. They were really pressed for action to go do surveys. And you have to do surveys as fast as you can to know as much as you can about what the problems are. And because we're home of Redstone Arsenal and everything, they got to fly tornado surveys in Apache helicopters. So we go out and tell people when we recruit, hey, you might be able to fly in do a tornado survey. Pretty cool. I don't do that stuff. That's, graduate students, they're sort of expendables.
That's a good helicopter.
Y'all remember me, 1974, that was a big one. So, when you count tornadoes, when you do a scientific, rational look at this, you do not say extreme weather is getting worse. What about droughts and floods? These are the real wet times or the flooding times. These are the droughts. Lots of variability, as you know, from year to year in our part of the world, but they're not getting worse, not getting better. Let's go globally. And globally, you see the same sort of thing. In fact, there's a slight downward trend in drought, but things are not getting worse climatologically. That's what we can do with numbers. And as much as I try to explain that to a certain senator or a congressperson who has a different view than I do about this, it just goes right over their heads. And they will, right after I finish, they will say the same thing. Oh, wildfires are getting worse, droughts are getting worse. We have fewer wildfires now than ever before, and because of management. But they're about 1/5 of what they used to be. What about hot days? So this is a chart that I made of the average number of days per station that went over 100 degrees in each year. So there's 1,114 stations, and it looks like, on average, the average station gets about 6 or so 100-degree days per year. Huntsville is way below 100, way below 6. And then 105 also here. Well, I think what you see there is you don't see a trend for sure, unless it's downward. But the 30s were real bad. The early 50s were real bad. 1980 was a hot one. But since then, we really haven't had much. In fact, the most recent years, stations around the country just have a tough time hitting 100 degrees because the temperature is just not as warm as you are led to believe it's warm. All science is numbers. These are the numbers. And these are government stations. How about Alabama? I built this time series. It goes back to 1883 and published it in the Journal of Applied Meteorology and Climatology. That shows for the state of Alabama, summer maximum temperatures, which is where the stress is, shows not an upward trend, but an actual downward trend. 1954 was a real hot one, as was 02, especially in South Alabama. 02 was real bad. Then it just fell off the cliff here. And we haven't had a real hot summer since. But if you came along around in here or something, you might think that's a really hot summer. But you know, some of these are going to come back one of these days. And so I hope we're ready with our air conditioners and everything. You know, Alabama used to have a thriving citrus industry back here. But because it's been colder than since 85 especially, we've just lost all that. How about losses from weather events? This is from Munich Re, the reinsurance company. That is a downward trend. That things from extreme weather, damages from extreme weather are actually declining. The raw dollar value is going up. But when you normalize it by people and whatnot, it's going down. And the reason is, the raw dollars are going up simply because there's more of us and we put a lot of stuff in the way of hurricanes and tornadoes. You've got bigger houses, a lot more houses. We've got 2 houses. People have stuff on the Gulf, you know, so a hurricane will hit it one of these days. But we, as we get rich, and around the world this is happening, we become, we secure ourselves, we provide security from weather disasters. We live in better homes so we don't get killed. Losses of life from weather disasters is almost down to imperceptible now around the world even, because of a better weather forecast, you know, knowing what to do when a severe weather approaches. So extreme weather is not making things worse at all. So views of dangerous climate change rely on models that fail simple testing and are not based on the evidence we have. Last time I testified before Congress, I did a very simple hypothesis test and showed them that I can falsify the claims of previous administration. But it's a political issue. And though it's been political all along, it really, the administration really ramped up its attacks on people like me on this date, February 16, 2014, when John Kerry in Indonesia, I think it was Indonesia, it was somewhere over there, Singapore, said that science is unequivocal. Okay, right there you know he's not a scientist. Someone says the science is unequivocal. And those who refuse to believe it are simply burying their heads in the sand. In other words, if you don't believe like him, you can't be right. We don't have time for a meeting everywhere of the Flat Earth Society. And climate change is the world's most fearsome weapon of mass destruction. Now remember what's going on in the world. And this is the most fearsome weapon of mass destruction? Oh, goodness. Well, I'll skip that comment I was going to make. It involved the defense department. Well, we hit back. Dick McKnight, a colleague of mine at UAH, and I wrote back in the Wall Street Journal right against his thing, saying, why Kerry is flat wrong on climate change. I did this chart. That's the first place this chart ever appeared. And it took me weeks and weeks to download 102 model simulations, extract out of the temperature data at all the different pressure levels, recreate the microwave emissions from that profile for 102 climate models, put it all together, get all the data, and this, which is something, I wasn't paid to do. You would think that with all those modelers, with their tens of millions of dollars, someone would have checked the real data with their outputs. But that's a scary thing for them. Anyway, so that appeared there for the first time. The reason we said why Kerry is flat wrong on climate change, it's because he used the flat earth thing. And we wrote in a piece, it was the scientists making observations that determined the world was round. Remember the Greeks, when they put the stake on the solstice, summer solstice, and the one down there in Alexandria had a different shadow length and angle than the one up north. And so they had pretty good calculation, actually, of how big the Earth was from those angles. So it was the scientists looking at observations. So we hit it pretty hard on that. And so I've been asked, since I'm a climate scientist who actually builds these climate data sets from scratch, to test the claims of all this stuff, I get invited quite a bit to Congress. And this is the one from last March and I was right next to Michael Mann, who was the hockey stick. And so we talked about old times. I should have put the political cartoon. There was a political cartoon that came out about this. He was caught twice, at least twice, lying, where he would say something and the congressman would ask him, would you repeat that? He'd say it again, and they'd pull up something, that said, well, this is what you really said. And so on. So he caught twice. So the cartoon has the four of us there, and Michael Mann is taking the hypocritic vote. He says, all you Koch-funded climate deniers. And none of us have ever received any money. This is New York Times came down and did a profile on me. And believe it or not, it was a fairly positive profile, which was unusual for the New York Times. And here I am, I'm opening up one of my climate logs that's 50 years old. I was actually looking at the data from 50 years prior that I had taken myself. All we had, was paper and pencils back then to do anything with them. Slide rule. Didn't have a slide rule. Slide rule should be right there. That's the ticket box, I think.
On the shelf.
I love the title here. Though scorned by colleagues, a climate change skeptic is unbowed. Because in this system of climate, because things are murky, you can't prove anything, you bow to authorities. You surrender your notion of how to think to an authority and let them think for you. And so I just like that, and so I was pleased with that. I'm bowed. I'm not going to bow to an authority when I've got real numbers to look at and check out this kind of stuff. So I mentioned about John Kerry. Well, the White House launched a campaign against 7 of us through this congressman Grijalva of Arizona. And they launched investigations on us individually because they just absolutely believed that if we had to be paid under the table to have the conclusions we did.
Oh no, they set the IRS on you?
So they just knew that that was the case, and so they had this investigation. We were investigated, each one of us. It was a real sad time in the sense that, you know, a climate scientist trying to do his job, he gets the federal government coming in to check his finances and so on. Well, many of you might know Paul Gaddis, you know, of AL.com. Yeah. He wrote a story. He called him up and said, "Why are you picking on this guy?" So this is what they said. The way we chose the list of recipients of this congressional investigation is who has published widely, who has testified before Congress, who seems to have the most impact on policy and scientific community, and he definitely fits that bill, and is profiled in the New York Times. If you were a typical faculty member, and that was your resume, you would be a star. You would be a star. In that administration, you had a target on your back. And I mean a target on your back. They were out to silence us. In fact, one of the fellows that they investigated, he was so fed up with the investigation, he just left the field. He just left climate studies and went on to something else. And in essence, remember what this says when the administration comes out and says something like this. All the agencies then know they have their cue. Okay, don't fund this guy. Make sure that impediments are put in their way to make any progress on it. Then the state's attorney general, you know, sued ExxonMobil for disrupting the climate. And in the complaint was this in the unredacted copy. Among those listed individually on the document are MIT Professor Emeritus Richard Lindzen and University of Alabama Huntsville climatologist John Christy. You know, sort of one of those persons of interest, you know, the criminal that they begin. California, you know, my home state is just falling off the edge of reality. They are considering, they did not pass it last year, they might soon, the California Climate Science Truth and Accountability Act, which authorizes prosecutors to sue fossil fuel companies, think tanks, and others that have deceived or misled the public on the risks of climate change. Because they have their view, very strongly in California especially, about what climate change is. If you disagree with it, you should be brought to justice, allowing legal action to be brought, extending back indefinitely.
When you do that in reverse.
The California sidelined the bill, but it still is on the table to be considered. Now, some people really get a problem. There was a March for Science. Remember, after Trump was elected in the inauguration, they had this March for Science. And I put it in quotes because it was nothing about science that I could tell. It was about a bunch of people that were real mad about Trump being elected. And so they marched all around, and the big theme of the march was climate change. In fact, in the Washington, D.C. march, right in the front was Michael Mann and Bill Nye, the science guy. Science guy. So
Sheldon there?
It was a big deal. And then later that weekend, someone came and shot the windows of the office building, the floor I'm on. The bullet here landed about 12 feet from where I sit. This is at 2 a.m., so it was someone who was just sending a signal. Planning to hit anybody, I think. So that's where this has gone to now. Here's the ironic. There's a lot of ironies here, but will politically forced regulations make a difference? Here's the irony of all these regulations and so on. The answer is no. If you believe climate models, and that's the temperature for the next 100 years, this would be the temperature if the United States disappeared. No people, no cars, no industry, nothing. And imperceptible, we can't even measure that kind of thing with precision. And yet, that is the irony that trying to put these laws that constrain us and make our energy costs go up, all those kinds of things will do nothing to affect the climate, except they make our economy harder to function. That's the real irony there. So the scientific method shows that regulations that impose higher energy costs will do nothing perceptible or attributable to whatever the climate is going to do. It's going to do what it's going to do. Now, the real world happens, believe it or not. Even in politically correct nations. This is interesting. I have a law of sustainability. If it's not economically sustainable, it's not sustainable. You know, people just don't give if nothing happens with the project they're interested in, they pull the plug. Well, the real world happens even in Germany and Japan. In an environmental push, these countries changed the energy mix to utilize less carbon and nuclear and more wind and solar. Guess what happened? Electricity rates rose to 43 cents a kilowatt hour in Germany, 26 in Japan. We pay about 9. Okay, now think about this. If you manufacture something that requires electricity, where are you going to build your plant? These are the costs of electricity for different countries of the world and states in Australia. Australia went real big into renewable solar and wind, and look at their costs for electricity. Solar and wind are so unreliable and so expensive. I mean, the energy density is just not there. You can't take wind, which is hardly any mass at all, and turn it into a blade to get much electricity out of it. Physics just aren't there. The U.S. is down here at 16 cents a kilowatt hour, basically because of the West Coast and the East and the Northeast. Those drive up the prices for everybody because, I mean the average, because they have all these mandates about wind and solar and so on, and it makes their electricity so much. And you know, Alabama is a beneficiary of that in the sense that industry is leaving California and coming to places like Alabama. So, you know, when I grew up in California, there were 8 automobile assembly plants. Now there's 9. Well, if you count Tesla, but. So the real world happened in Germany and Japan. Here's another irony. Guess what happened to their CO2 emissions? Their CO2 emissions rose. And they're rising now. Why? Because you have to have backup for your wind and solar all the time. Because you don't know when it's going to go off. Well, you do know when the sun's going to set. You don't know a whole lot about clouds. So you've got this spinning reserve producing carbon dioxide all the time that you're not using. In fact, Germany is building more coal-fired power plants to back up these things. Japan is building more coal-fired power plants to back up these things. Their CO2 emissions are rising. Ours are falling because we have a market economy, more or less a market economy. And it turns out natural gas is cheaper. Now price is coming down versus coal. You get more bang in terms of CO2 emissions from the natural gas, fewer CO2 emissions. And so our CO2 emissions are going down. And we don't have any laws, or at least try not to, on that. Worldwide, there's going to be, I think about 1,100 planned new coal-fired power plants around the world, because it works. You know how much coal you've got, you can shovel it in that machine, and you have an on-demand economy. You can't have an economy that only functions when the wind blows and when the sun shines. In Alabama, we have something called clouds, too. And that really is a damn rough. So don't get me started on those solar panels down there on the Parkway. You do a cost-benefit analysis of those things, and you will go strangle the mayor. Cut that part out.
Have you seen that bunch you put out on the arsenal?
I don't want to know. What's happening with coal use around the world? Look at this. Yeah, everybody else can put 2 and 2 together. They can connect 2 dots. Coal means power and life and a functioning economy. Let's get that.
Oh no.
Don't realize all the pitfalls of something like a windmill, especially in the higher latitudes. Now think about this. You've got this multi-million-dollar investment. It's sitting there doing nothing because these blades at the tips are spinning over 200 miles an hour. They throw a chunk of ice off, somebody's going to die. So they have to stop them. The amount of energy it takes a helicopter to stay up there and spray the ice around there is as much as that thing will produce in a year. So,
Whoa.
I don't know why that quote ended up there. Here's another way to look at it. To produce the same amount of electricity Takes one guy in the coal industry, two guys in natural gas, 79. You know, is this solar? Yeah, solar. Guess why solar costs so much? It takes too many people. You know, money only goes to people. It doesn't go to things. It goes to people who make things. So you've got to put money in 79 people's pocket to get the same amount of electricity you put in coal miners' pocket. So climate change is a moral issue. So this is the third part of the talk, and almost over. Now I have to step away from science because I have to figure out a value for human life. Okay? I can't take you and put you in the lab and measure you and come up with something called value. I don't know how much you're worth. But I bet I can get agreement that whatever it is, it's a big number. Every one of us thinks life is worth a lot. Right? For those of us who have experienced the loss of dear loved ones, you would say, I wouldn't give anything for their life. I would give everything for their life. That's how much human life is worth to us. So if we can just establish that fact, human life is worth a lot. Okay? We can go back into science. So if human life is worth a lot, then you want to make it longer and better. A longer and better life is worth it. And as you can see here, that happens when you have energy. Without, as I often say at Congress, you know, having lived in Africa, without energy, life is brutal and short. And we don't like that. Nobody likes that. In fact, we are able, thanks to energy production, our life expectancy has shot up. Even though the population has shot up, the GDP per person has shot up even more. And did you know we are producing about twice as many calories, food calories per person now as we did 40 years ago? We know how to make things. We just get smarter and smarter as time goes on, and we unleash innovation and so on, and we can just cover that. We make things better. Poverty rates around the world are declining like crazy because energy is there available for these kinds of things. Now, if you are concerned socially about the energy issue, this is the chart that you need to pay attention to. If you want to help the poor, the first thing you could do is lower the energy costs. Cut the price of gasoline, cut the price of electricity. That goes right into the pockets of the poor person. This is the proportion of their income that is paid for energy. Now, you know, most of us are way up there somewhere. We don't pay much for energy. Another nickel per gallon gasoline and so on like that. But for a poor person, those energy costs are huge. And so when you increase the energy costs, as the last administration did, the first people that were hurt and were hurt the worst were the poorest among us. And you think about it, you know, everybody drives a car, whether you're rich or poor. But your gas tank's the same size. So that poor guy, when he fills up his gas tank, it's going to cost him a lot more out of his pocket, proportionally, than the rich guy fills his gas tank with the same gas tank. If you want to hurt the poor, increase energy costs. That will do it quicker than anything else. And the last administration did that. But as you, well, that's in the wrong place, isn't it? So the real world happens in the developing world. Affordable energy vastly improves the quality and length of human life. I think we've said human life is valuable, extremely valuable. Therefore, improving its quality and its length is a good thing to do. Morally, a good thing to do. The most affordable path for that right now, today, is carbon. And as I mentioned, I was a missionary in Africa. I taught physics and chemistry at Uri Baptist High School. And just a great, great experience. I remember in physics lab, in fact, it was this one, we had a little refrigerator in the back. And so I had some ice, and you needed ice because you're doing a latent heat lab. So you melt the ice, see how much temperature changes, so on. They had never touched ice before. So when I brought it out in the university, it would say, it burns. It burns. Well, if you think about it, you've never touched it before, it's such a different sensation, it's probably painful. So it feels like a burn. Most people go to see the reticulated giraffes in Samburu or somewhere. I was there to teach kids and just had a terrific time. But here's the energy system in Africa. The energy source is biomass. The UN estimates that to get that energy, the average woman walks about 3 miles to the edge of the forest, chops down about 40 to 50 pounds of wood, puts it on her back, and hauls it home. And that's the energy transmission system. The energy use, by the way, I would occasionally have our school band driving a soccer team somewhere, and these ladies would jump out in front. They didn't understand the notion of inertia and braking distance and all that kind of stuff. Because they knew that the amount of energy I could hold in the palm of my hand, cupped hands of petrol, was enough to get them home. And they would give anything to have an SUV rather than do this. Let me tell you. Here's the tragedy. Is the energy use is that it's burned in the home. You can see the aerosols there that are toxic. The UN estimates today 3 million children per year die from respiratory illnesses of this kind of energy system. 3 million dead per year right now. That many children die because of this. And I can assure you that African parents grieve inconsolably, just like you and I do, when a child is lost. And so this kind of system, they do not want. They are moving away from that kind of thing. And building and coal-fired power plants is the best way for them. So if you value human life, that means you want to avoid that kind of energy system. And here's the thing, too, about CO2 emissions. India and China are driving the bus now. They're expanding and growing, so their emissions are way above ours. This is the United States because energy is a cost in the market economy. It's a cost, and so we constantly try to figure out how to make stuff with using less energy so we can get things more efficiently. And so our emissions are actually flat. So the real world happens. The U.S. share of CO2 emissions has fallen from 28% in the 90s to 14% today, 12%. We're just not the big emitter anymore. The rest of the world is catching up to a modern lifestyle. So, just like everywhere else, without energy, life is brutal and short. Remember April 27th, 2011, when we didn't have power for 5 days or whatever it was? That was no fun.
I did too.
I remember the law of sustainability was expressed this way by the environment minister. He said, what CO2 cuts? He was responding to some environmentalists. What CO2 cuts? That's for more developed countries. The moral principle of historic responsibility cannot be washed away. India's first task is eradication of poverty. 20% of our population doesn't have access to electricity, and that's our top priority. We will grow faster, and our emissions will rise. I think fully for him. So there's my law of sustainability. It's not economically sustainable. It's not sustainable. Lifting people out of energy poverty with carbon today, because that's what's available today, is morally right. If you value human life, it's morally right, and it's going to keep happening everywhere else, no matter what the U.S. does. So, to conclude, what do the numbers show? The scientific method demonstrates the current theory of CO2 warming of the climate is out of step with reality. The extreme weather events we care about are not increasing in frequency or intensity. Punitive regulatory controls will do essentially nothing to change whatever the climate is going to do. CO2 emitting coal is increasingly powering the world's economies, including Germany's and Japan's, along with developing countries, no matter what the U.S. says. What does my experience say? Climate change is a political issue, and there is a cost for those of us who are not politically correct. And finally, if there is value in enhancing the quality and length of human life, the moral imperative is to expand access to that which is available today. Low-cost, carbon-based energy, and it's happening anyway. Okay, wait a minute. Yes, I have one more. 2 cavemen are talking. Something's just not right. Our air is clean, our water is pure, we all get plenty of exercise, everything we eat is organic and free range, and yet nobody lives past it. Okay, thank you very much.
Take a few questions, so if you want to raise your hand, we'll try to do that. I think we got one here, and then Hugh and Larry, so we'll start with you, sir.
Might be a little politically incorrect, but back to the very beginning of your presentation where you mentioned Alabama has an excess of energy and California deficit in need of energy. If we were to stop exporting to them, would it make a difference? would it cause them to go away?
Something would happen if Arizona, Utah, Wyoming stopped sending their power that way. There would be I think you'd see a change in administration out there.
Hugh?
Yes, John, a lot of what you say depends on modern day measurements, particularly using satellites. For some of us, maybe most of us, those somewhat arcane methods, are they settled and agreed upon? Does anyone question the methods of the measurements or the actual measurements themselves, or is there general agreement on them?
To first order, there's a general agreement. Yeah. Those are accurately measured. The different groups, the federal government has a time series that's a little different from ours. It's warmer. In fact, it's the warmest one, but that's what they always do. I just had a paper published last week that shows the problem with those data sets. But the range isn't that much between them. There's no way you're going to get a data set that shows what the models show. Data sets show.
Let me just follow up. I presume that among your other qualifications, you are a psychologist, because most of us are. How do you understand, as your pal Roche would say it, algo? Could he actually believe what he says he believes?
Now he gets paid for it.
He's making money.
You know, it is. It would be fun to get inside his brain and find out how.
There's a void there.
It's you know, the fundamental question is, why do people, you know, if they see a presentation with facts and things like that, why do they still just so much believe it? Because they want to believe. Scientists are people, believe it or not, and they believe what they want to believe. And that colors the way they do their science and so on. And there's just, you can't imagine the drug it is of attention. And I saw this when I was in the IPCC and everything. That when you've got cameras coming in on you and you're on the nightly news and you're called by the New York Times and all this kind of stuff, you don't want that to quit ever. So you come up with scarier scenarios, more outlandish claims and so on, and so you can always keep in that mindset mode.
Larry?
I got one question divided into two parts. Number one, why do the climate change advocates refuse to acknowledge the influence of the sun? And then two, who are the real beneficiaries behind this fake climate change argument?
Okay, number one is a simple look at the solar output change in terms of watts per meter squared. It's very small. And so you would say, well, that can't affect the climate much at all. What turns out to be is that there are secondary, that we now know, but they still, as you said, like to refuse to think about that, so that there are secondary effects of that variation in solar wind, you know, the 11-year cycle, and so on, and that those variations change cloud cover. And it looks like that's a big, big factor, because as you know, clouds can either reflect the light or let it in. That's a lot of energy. So just that tiny change of energy, which actually changes the amount of cosmic rays that come in through the magnetic field, that is enough to change cloud formation. And you change cloud formation 1%, 2%, and you have changed the energy budget of the planet. So I think more and more there's a little bit more notion that the sun might be kind of an interesting thing to study in terms of climate. But there's still a lot of questions on it. The second part is a really good question about what's the motivation here. I'll tell you a story about, I was in Albany, New York, somewhere near Albany, where GE has its headquarters, General Electric. They were unveiling their Eco-Imagination initiative that I don't think they have anymore, but Eco-Imagination, they were kind of, you know, becoming green and that kind of stuff. The guy announced their business plan, and it was almost using these words: Our business plan is to get the government to force the public to buy our product because they wouldn't otherwise. Almost exactly. And so they lobbied as hard as they could with the green groups and so on to have these renewable standards, these windmill requirements, these solar panel requirements. And what does GE make? You know, they make those kind of things. So there is money in corporations that deal with that, with renewable energy anyway. Other people are just true religious believers, you know, that we are an infestation on the planet and we need to have the smallest amount of impact as possible. You know, we need to get rid of 90% of us somehow. They never volunteer, though. Others see it as a, and this is a theory, I think it has something to it, the Russians have used it quite a bit, as a way to control. When the Berlin Wall collapsed, there was a lot of communist sympathizers. They had to have an issue. And this was an issue in which you could have some kind of global control of governance if you had energy control. You can't do this, you can't do that. You can only build a planet if we say so. You know, that centralized planning. I mean, the world has had plenty of examples of centralized planning and how it just failed. People, especially environmentalists, think that that's the way to go. Centralized planning. Yeah, as long as they're the planners.
Right.
Linda?
Yeah, I just got a real quick question. Going back to the Australia, New Zealand thing, Johnny and I were with a number of New Zealanders. We were in Hawaii on a snorkeling trip. They hated the United States, and we personified that because they honestly believed that our hairspray caused the hole in the ozone layer, causing them to have melanoma. Therefore, we were responsible, not their red hair and light complexion, we were responsible. Is that driven their decision in that part of the world to go? Are they buying the whole ozone layer?
Well, remember, Australia and New Zealand do have this centralized planning notion, and it goes back to the divine right of kings in Europe. That
Right.
The king had a divine identity from God, so you follow the central planner. And they kind of still have that notion. But, you know, do the numbers. Up there, that far away from the pole, that's not going to be your hairspray to anything.
Well, I knew that. Was it driving them to make those
Yeah,
decisions?
that environmental issue was one that they were particularly concerned about because the ozone hole was over the South Pole. They're in the southern hemisphere, you know, down there 30, 45 south. So, yeah.
Carl?
The Paris Accord is always, I've always been confused about it. It's clear it's a central planning aspect, but a few countries were going to contribute, and then somebody was going to take all those funds and distribute them by some formula of their making, apparently. Who is that? Who did they think was going to take all these billions of dollars and redistribute them to these other countries?
Well, remember how this is done. It's done by vote, and every country gets one vote. So if you're a country, don't you want to vote to have the richest guy give you money?
Exactly.
So that's really what it boils down to. But, you know, the actual scientific effect of Paris Accord was negligible. You know, it wasn't going to affect the climate at all. It was mainly about a redistribution of wealth away from the rich countries to the poor climate flip. So pulling out of it is a smart thing to do.
Yes, sir.
Go ahead.
Question for you, sir. How much uncertainty is in the reconstructions of past temperature data?
Depends on the paleo record. The thing I showed has real small error bars because it's a precise measurement of temperature. A borehole temperature measurement is where you dig an ice core, take out the ice core, fill that hole up with glycerol, let it equilibrate in terms of temperature, then drop a very sensitive thermometer down it. And as you go down deeper, you're going back in time. Because the forcing of the temperature of that column happens only at the surface, not from the sun. So as you go down, you go back in time. The reason those have small error bars, and like the medieval period was warmer than the Little Ice Age and so on, is that you can go and repeat the experiment in another borehole and get the same result. You go over here, repeat it, get the same result. You can't do that with tree rings. They're all over the place in terms of their results. So, but your fundamental concern is correct. Paleo reconstructions, you've got to look at them carefully. A lot of them are just terrible.
All right, all the way in the back.
First, thank you very much for sharing your years of experience and knowledge, and it's very enlightening. And I was just wondering, you mentioned market-driven economy a couple times as far as power generation. What do you think about thorium? Is there a place in the market economy for thorium to replace the nuclear fuel?
You know, I haven't looked at that carefully enough. I've seen some blog posts on it that it looks like a way to create the energy that we need without the nasty leftovers. I just look back at the market economy and say, if it were easy and cheap to do, somebody would do it.
Well, the Chinese are. The Chinese are building the pebble bed reactors right now, and they're using it.
Okay, then it'll spread.
Yeah.
Mary Lynn.
Now, you do hit something though hard. In this country, anytime you say something with nuclear, it goes through a regulatory commission that is just a nightmare. And so we have regulatory red tape that holds everything.
I noticed that a climate model that can't predict the past is faulty. Is there not some way to challenge the people with their...
I do that every time I write a paper. And in fact, the latest paper that was published last week, I have right in there. Here's what the models say, here's what the observations say. Statistically, far different, therefore falsified. Just goes right over the model.
Yes. Dr. Christy, okay, being in the air conditioning and refrigeration business, we went through the ozone hole with the ozone depletion potential on refrigerants, and now we're getting into the global warming potential in the next wave. So they're talking about changing refrigerants again in the next few years. Do you see anything in the ozone or the global warming of the CO2 or any of these other chemicals?
We've seen no real change in temperature at the South Pole stratosphere, which where the hole is.
Yeah.
It's cold. We've seen no change in temperature in 20 years there. What these new chemicals might do, I don't know. The whole thing was, does a fluorine atom get separated and get up in the stratosphere and short circuit the ozone formation cycle?
Yeah, well, it was chlorine was a boogeyman. Now it's going to be fluorine. Like I said, they're talking about propane being one of the major components of these new refrigerants. So then everybody's worried about flammability and explosiveness and everything else.
In aerosol, excuse me, in refrigeration, that propane, you're correct. They took that out of aerosols back in July of last year. Honeywell came out with a new chemical, as EZ-134, that replaces R-132.
You know, the reason those things can change is because there are new chemicals available.
Yeah.
And the companies lobby very hard in Congress for those kinds of laws because they can make a new material and sell some new stuff.
That is true, because the 134 dropped to $3 a pound, and the EZ-123 is $9 a pound. So Honeywell's making that 3 times the amount of money.
Do we have one more question over here? Yes, sir.
My first exposure to this subject was a book by Michael Crichton.
Oh.
And one of his interesting essays made the point that you were making, that basically you don't prove science by consensus, you prove it with numbers. You repeat the experiment and you can show what's true. Did you meet him? Did he come and talk to you? I'm just curious.
Yes. Michael Crichton and I exchanged many emails, and he used satellite data, if you remember, in the book. It was good news here. And the story about that I like to tell is that my son was a teenager at the time, and you know how much respect a son has for them. Well, one of the emails, I always called him Dr. Crichton. You know, he's a medical doctor, researcher, he got his medical degree at Harvard. And, you know, I had already written Andromeda Strain by that time as a millionaire. Just made the other students mad because he was brilliant in class and still became a billionaire. Did his postgraduate work at San Diego, University of San Diego. Well, one day he said, "John, just call me Michael." And I showed that to my son. Then I was something.
Well, thank you, Dr. Christy.